Welcome to the Are You GCSE Physics Ready playlist. This playlist is packed with example questions and guided solutions for every GCSE Physics topic. So it's the perfect tool to help you test your understanding. If you feel like you might need a quick review of this topic before having a go at the questions, or you would just like the ideal revision companion for these videos, then do make sure to download my free GCSE Physics revision notes, linked in the description below. If you're ready, let's dive in. Okay, so explain how we can arrange 3 resistors, each resistance 2 ohms in a circuit, with one cell to first maximise resistance and then minimise resistance. So actually it's irrelevant that these resistors all have a resistor of 2 ohms, that's an irrelevant piece of information. If I would like to maximise the resistance that I can have with these 3 resistors, I should put them all in a line or in series with each other, because that creates more obstacles, if you like, for the current to try and get through. So effectively, I am increasing the resistance of my circuit by reducing the amount of current that can flow through my circuit. And so I am here to minimise the resistance. What I want to do then is I want to take those 3 resistors and put them all in parallel with each other. That way, I basically open up more pathways that my current can flow through and down. So in that way, I can allow more current to flow in total through my circuit and effectively, therefore, have reduced the resistance of my circuit. Okay, a bulb is in series with a variable resistor. State and explain what happens to the brightness of the bulb as you turn the resistance of the variable resistor up. Okay, let's first have a diagram so we can see what is going on here. I've got a bulb in series with that variable resistor, and then I'm going to increase the resistance of that resistor. What that will do is that will decrease the amount of current that is therefore flowing through that resistor, because it's harder for the current to get through. And actually, since my bulb is in series with that variable resistor, and in a series circuit the current is the same at every point, by decreasing the amount of current through my variable resistor, I have, of course, decreased the amount of current that is flowing through my bulb, and therefore my bulb will be less bright than it was before. Okay, design a circuit to give the IV characteristic below. So this is an IV characteristic that has this directly proportional line, and that lets me know, since this line has a constant gradient, this component must have a constant resistance, so it must be just a fixed resistor. So if I were doing this in my exam, the first thing that I need to do in designing one of these experiments is draw a circuit diagram. And this actually does a lot of the legwork for me, because if I draw this diagram here, I need to make sure that I've got an ammeter, I've got a voltmeter, and I've got a variable resistor in my circuit. Okay, those are the things that I need other than my cell and my fixed resistor. My voltmeter needs to be in parallel with the resistor and the fixed resistor, that is, and my ammeter needs to be in series. So I've drawn my ammeter in the middle there. It could actually have been anywhere in that circuit. So I would say I'm using the voltmeter to measure the voltage, and I'm using the ammeter to measure the current. And what I do then is I adjust the resistance using that variable resistor so that I can get different values of current and voltage over my fixed resistor. So I'm going to adjust that, maybe suggest between 5 or 10 times. I've gone for 7 here, so that I can have 7 different readings of current and voltage that will allow me to plot this graph. Okay, how can I calculate the resistance of that resistor? Well, I use the graph and I say, where would I like to calculate the resistance of? So I take a reading of a particular current and voltage and use my equation we've done in previous topics. Voltage divided by current is equal to resistance. Sketch a graph of a lower resistance. So we should know for these IV curves that effectively the steepness of the line is kind of like a 1 over your resistance, in the sense that the steeper your line gets, that indicates your resistance is getting smaller and smaller. So So if I want a graph of a resistor with a lower resistance, it needs to be a straight line with a constant gradient because it's got a fixed resistance. But I want that resistance to be smaller, which means I actually need a steeper line on my graph. Okay, explain the shape of an IV curve for the bulb below. So this is a classic filament lamp curve. And basically, first, in order to explain it, I need to say what's going on. We've got this thing here where we get a gradient getting shallower and shallower at those higher currents. Okay, so then we need to think about why that is. Now, if my gradient is getting shallower and shallower, remember it's the opposite thing happening to my resistance. My resistance is getting larger and larger at those high currents. So that's kind of describing what's going on, and now into explaining it. At high current, I have a higher temperature in my filament within my bulb. And what that means that within that filament, the positive ions that my electrons are trying to move through are vibrating more at those higher temperatures. So that's actually making it harder for the electrons to make their way through all these ions that are now vibrating more vigorously. And that in effect means that I have more resistance in my filament bulb. The harder it is for my electrons to get through, the higher my resistance is. Remember, my electrons moving through, my current is essentially my coulombs moving through that wire, and coulombs are just a large group of electrons. So the harder it is for my electrons to get through, the harder it is for a coulomb to get through. So that means I've got a lower current. Okay, describe what happens to the resistance of a diode as my current increases. So I'm just quickly adding my labels onto that graph. That was very rubbish of me. Anyway, this is my graph for a diode, and what you have is that those larger currents, my line goes straight upwards. And so a really, really now steeper gradient than it was before indicates, remember the opposite for my resistance, gradient went up, so resistance dropped or went down. I've kind of written that here. My resistance at any point, I can take the voltage at that point and divide it by the current at that point. And if I want a more vague way of doing it, it's basically like 1 over the gradient. So as the gradient gets steeper and steeper and steeper, resistance gets smaller and smaller and smaller. Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not? Okay, tips and tricks for this section. Yeah, the first one is that classic circuit with a variable resistor, ammeter in series, voltmeter in parallel. To find these IV characteristics, you need to know how to draw that circuit straight away and to use that circuit if you're ever asked to design this experiment. Gradient and resistance, yeah, just this idea that gradient gets bigger, resistance gets smaller, and having that idea in your head when you're looking at these IV curves, and you can tell me then straight away what is happening to the resistance of these components as you apply larger currents through them. Filament bulb, current and heating, yes, I feel like this is quite a fixed answer that is worth learning as to why high currents through things like filament bulbs or just metals increase the resistance of those metals. So breaking it down into points, you've got high current means high temperatures, means your ions vibrating more and the electrons finding it harder to get through. So effectively, you've got that high resistance.